This meeting is being recorded.
Hi everyone. Today we are going to talk about one of the basic implementation using classical machine learning algorithm called IsolationForest. I've already created the application and it's being hosted on Medium. If you see here, we'll be doing this as a full hands-on example. But prior to that, I'll just like to go through the concepts behind the algorithm and the intention what we are trying to attain at the end of the at the end of running this particular file. So the example I'm taking here is to detect anomaly in the logs. Consider an example, like for any application, if we see how the application is behaving, or we want to monitor, or we want to check the status of our application, we generally, and obviously we start from the logs basically. So using this classical ML, we need to see how it will detect the anomaly in the log. Now, before we go ahead, we need to understand what does anomaly means here specifically. So if you take this example, for illustration, I've taken here a log from Splunk, an example of Splunk log. If you see here, it has specified, okay, I have the particular STD point being called in this particular pool. Here by pool, we can understand a cluster or any container probably where we have deployed. And then we have the error code message. As a standard practice for any log, we'll have a level defined. Now, if we see this particular example, we see the line number 2 here appears to be anomaly. How? Based on the feature level. Here by feature, we understand the different keys. So if now going further, we need to see how we can make LLM to predict the anomaly based on the given attribute, or in other words, the features. So here we have used the library pandas, NumPy, matplotlib to give the visual representation, and Cbun and the warnings, and also the scikit-learn library. Now, to be specific, what is the classic ML I was talking about is the IsolationForest offered from scikit-learn. As a very first step after loading all the dependencies, if you see here, we'll be reading the CSV file. For illustration, I've kept it in my local as a log data, but in a real time, it should be something I understand we can simply load it from our endpoint that is being offered, say, for a Splunk log or using SDK and at a runtime. But in interest of time, I just already downloaded and kept it into the location parallel to the file. So as the very first step, we upload the file that has data in which we need to figure out the anomaly. Then as per the panda and the data file representation, if you see DF is something nothing but we have imported it. This is a data file basically, and we are reading it using the pandas. So as a prerequisite to train any model, we need to convert the features or the keys that we get as a part of the log to numerical representation. So we have, for illustration, I just done for two. One is level and one is critical. So level here says error or info, critical says whether it's actually critical or no. And then we'll be using inbuilt library called label encoder, and we'll ensure like whatever endpoint we define using label encoder transform the features that we need to train against. Like HTTP endpoint, we have taken one, and the pool is the other one. And herein, if you see this line, we have taken it from data file as a features to use, and these are the features we are going to determine the anomaly based on? Basically, if you say level numeric. So level numeric is nothing representation of a level. Level is nothing in turn. It's a level of error of log error or info. So it will judge based on the level. So after that, what we do, we define the correlation matrix. That is not that is could be used here just to see how what are the features that affect the result proportionally equivalent. I mean, if you see, if suppose we had another column corresponding to level, suppose error code, then obviously we would have error code corresponding error like say 500. Info could be 200. For example, if you zoom here, so wherever info will be there, it will be 200. 1-to-1 error will have 500 1-to-1. So we could neglect that particular attribute. However, I've not covered that. Just for example, I'm saying what exactly the correlation matrix, but we can skip that if we want to for now. As the next step, it will fit the features, means it's saying this feature has to be scaled, and then based on the confirmation here, contamination, we are saying we are passing it to the isolation algorithm that will do the all magic behind, and we are specifying the contamination as 0.01, means this much of deviation is allowed. How this can be added? This is like a configurable thing. It depends on the use case up to what variation we are expecting contamination to be. This has to be tweaked along with the based on the data set what we want to train. Once it's fitted with the scale feature, this is the line basically that will run the prediction, and based on prediction, whatever we say the LLM power is, it will predict here behind the scene, and anomaly count would be made total and would be captured here like the number of anomalies we have, and answer will get something like this. Now the question comes, why predict -1 appears? How does it determine? It's basically it's deviation in the negation -1. 0, had it been not equal to -1, it would not have been considered as an anomaly. We'll just try to run this in local and we'll see if it works. Let's copy it here. I'm assuming that I have all the dependencies. Now let's copy the content as well. Content here, I'm the log in which we want to figure out the anomaly. We'll put it into a file called log_data. Okay, it looks like we already have the data. So see, we have error, and so let's run it and we'll see if it works as expected, if everything goes fine. Let's check out if you're in the same directory as expected. Okay, let's run it. Okay, so we got some indentation issue here. Okay, we would rather comment it out. So if everything goes fine, it should work. Okay, so we got the answer here. Okay, so there's an error, means it's not able to determine what is NP. NP here refers to DP is not defined. So by DP, where DP is being used, let's check it out. It's in line number 17. DP, okay. Let's check it out. Maybe while copying. Okay. See, this is the typo. I have to be very careful going further. I'll ensure like this is not being repeated. Sorry about this. Okay, one more error. PD is not defined. Line number 15. Okay, that's pandas actually. Okay, that's the mistake. This should be DPs here. I've given the whole detail here. Somehow this has been missed. PD. So PD I have referred here in the line number 15. Does. That's correct only, I guess. PD is DP. For DP it was complaining. You say DP. Looks like should be DF, I guess. Keyword level, okay. Mhm. Check out what level is there. Okay. I think this is probably I'll be covering the next session altogether. This looks like I have a miss while pasting the data here. We'll be back with another video. But if you see, here I've explained everything in the detail. Thank you.